Yes, can you see the OneNote page?
Yes, sir, it's visible.
Okay, today we shall discuss about laser-based strip profile gauge. This is useful to monitor the flatness of various kind of uh, plates like steel plate, aluminum plate, copper plate, or even it can also be used to gauge the profile of wooden constructions, can also be done for profiling of a flat surface. Now this one, there are two kinds of profile gauges. One is interferometer based and another is the simple laser line based. So today I shall discuss about laser line based profile gauge. So this is used for measuring the flatness of various plates, bars and surfaces. For example, steel plate in the rolling mill. So basically flatness need to be controlled uh, for quality products. Say for automobile industry, we require steel seats, and for that purpose, the flatness is very important. So that need to be controlled within, say, a fraction of a millimeter or so. Interferometric or ellipsometric flatness gauges usually measure in micrometer or fraction of micrometer. But laser line based flatness gauges can resolve up to a fraction of millimeter, 0.1 or so. So this method is also known as the shifted image technique. Again, the basic advantage is that it is a non-contact method and can be done from a large distance. Distance is important. Usually, say in the rolling mill, the seats will be moving at a very high velocity, like even 1 meter, 2 meter per second. So therefore, uh, it has to be non-contact. And furthermore, in hot rolling mill, there are high temperature near the sheet. So therefore, uh, usually this is installed at a quite at a distance of several meters. So the basic principle is known as the shifted image. The lines that I am drawing is not very flat. Anyway, these are, say, a surface. Say original, there is one plane is at y1, another plane at y0. They are separated by a height of h1. So this is a laser diode, and here is a lens, focusing lens. The imaging lens is somewhere here. This is a camera. This camera can be a linear scan camera, that is one dimensional array is only there, or area scan camera. If we want to resolve the flatness in two directions, then we have to use the area scan camera is the kind of the two-dimensional camera that usually we use. Linear scan camera is a one-dimensional camera. The advantage of linear scan camera is that its resolution is very high. There could be 4K, 12K, or even 64K or 64,000 number of elements can be there in one camera. So therefore, we can resolve it into much finer fashion. Now, area scan camera has the advantage that the flatness can be resolved in both the directions. So this is the angle theta. So this is usually a series of lenses are there. Generally, a projector is used in this place, a lens projector, to make this projection quality better at this point. Now, the basic principle is that suppose the plate was at y1, okay. So then what will happen? Then the corresponding image at the image plane will be at this point. And if the plate is at y0, then the corresponding image point at the camera will be at this point. So therefore, this shifting image, shifting pixel is proportional to the change in height. Change in height, that is h1. Now, how it is happening? Basically, the basic idea is this perspective view. So to resolve height, you know that we have to look at an angle, then only we can differentiate height in a monopolar vision. So therefore here the laser is viewing the surface at an angle, and the camera is also viewing at an angle. The camera could be one of these if it is at an angle. Then also there will be change in shift in pixel. So that is possible to monitor the change in height. But generally it is kept at an angle, especially in case of hot surface, because then what will happen, the heat evaporated from this surface is not directly captured by the camera. So heat energy will not be directly going to the camera, so therefore it is kept at an angle. Now this can be extended to multiple points very easily. So if we are looking at multiple points through a laser scanner or a laser line, then this is H1, H2, H3. So the undulated plane is this one. And this is the reference plane. This is delta x1, delta x2, and delta x3. These are the angle, that viewing angle is theta 1, theta 2, and theta 3. Theta is the angle of projection. Usually theta is assumed to be constant. Hi undulation is much less, assumed to be much less compared to the stand-off distance. Otherwise, actually, the undulation will not be covered in the depth of focus of the projecting lens. So we can write hi equal to del xi tan theta I. This is in the global plane. And in the camera plane, hi is delta yi tan theta I. K is the camera calibration constant or matrix. So this camera calibration matrix is required corresponding to the various parameters of the camera, viewing angle of the camera, pan, tilt, zoom, etc., and also the angle of view. Now, this can be further extended to a two-dimensional undulation. So these are the laser lines projected onto the surface. Now, if the surface is flat surface, on the image plane, say, let us take another line here. Or maybe just two lines. Okay. These will be straight. The image will be straight. Now, if the surface is undulated, sorry, okay. So this is the undulation portion. So So again, these are the, I think I have learned only. These are the ledger lines. Now in the image plane, so there will be, this image will be shifted, and depending on the undulation, that is if it is up or uh, down. So undulation is a downward undulation or an upward undulation, the shift will be towards left direction or towards right direction. Shifting image. Is towards left or right. Depending on upward or downward undulations. So therefore, if I can project many number of lines, because now laser line projectors are available with specified number of lines, we can have 256 lines, 5112 number of lines, such that this surface can be gauged as a finer interval. Available with 256, 5112 or even 1024 number of lines. Or more. The same thing can be done from ordinary projector as well. This angular illumination can also be done using ordinary projectors. With a pattern plate fixed in front of the projector. Or in case of today's digital projectors, we can simply load that pattern. Simply be loaded on in the projector, loaded to the projector. The disadvantage of using projector is that the lifetime of the or working lifetime of the lamp. So that is the main disadvantage. Continuously, if it is on for certain hours, usually you switch off due to temperature rise. So therefore, generally projector based system is used for doing just for inspection. While laser line based systems are used for online application. So that means it has to be on for 24 hours and usually work in the control loop. So therefore it cannot be made off suddenly. The resolution of course, this projector-based system is much higher because we can have a very fine pattern projected to the plane if the lens quality is good. Say for a simple camera of 1024 pixel and coverage 300 mm. So 1 pixel corresponds to 0.3 mm. So therefore this k delta y tan theta I, so that is actually 0.3 mm 1 pixel. So theta I, if it is 30 degree, tan theta I could be theta I 0.866 or 1 by 1.732. So then the resolution could be a fraction of millimeter. Flatness is of the order of a fraction of millimeter.
Sir,
Yes.
sir, that 1024 we are approximating as 1000. Sir, always will approximate as power of 10.
Because of implementation, camera fabrication or manufacturing. So usually they are made in 2 to the power.
Sure. Okay,
So,
sir.
but for
Thank you,
one
sir.
dimension, it can be 4096 or even more than that. So this resolution could be better. But you have seen that today's cameras are available with very high resolution. Even two-dimensional cameras are available with 5 megapixels or even 12 megapixel industrial camera is also available. Generally, industrial camera are very costly because of the uh, fabrication care that has been taken. So, and also because the number of camera those are sold to the industry are very less. So because of that, say 12 megapixel camera is very common and very cheap in your phone, but the same 12 megapixel camera, of course the lens and other things are separately fitted, but even the camera will cost around uh, somewhere between 5 lakhs, but the lens is also very costly.
Sir, and is that number of pixels dependent on the number of laser lines that we are using?
No,
Sir,
it is the camera resolution. Laser line is a continuous laser line. Okay.
sure. Okay,
So
sir.
it is laser lines are like if there is a laser point laser and then here a diffractor is this is a laser and diffraction optics is here. So by the diffraction optics, it could be a simple cylindrical lens as well. Okay. So a cylindrical lens means lens basically diverges this point laser beam uh, in both the direction, but cylindrical lens curvature is in one direction. So therefore laser it will be a line. So it will be a simple line here. So it will be diverged in only one direction. And this is the divergence angle. And usually lasers are available with various kind of divergence specification. So that can be done at the manufacturer's end, or otherwise an extra lens can be, cylindrical lens can be given to manipulate this angle. So accordingly at a distance you will get, suppose you have theta equal to 30 degree. So depending on this distance, you will have the length of the laser line. So it's a continuous line. So therefore, the resolution will depend mainly on the camera resolution and the quality of the laser line. So because here there are diffraction optics or even lens, there will be certain amount of inhomogeneity in the line. Laser line is not a perfect line. So because of that, of course, the analog resolution will be determined. But mostly that is well controlled nowadays. Commercial laser lines are available. So mainly it depends on the camera resolution.
Sir, if we increase the number of laser lines, then sir, how would the image be affected then?
Yeah, number of laser lines has to be done for this like two-dimensional case. So there are two options. One is that we can have a mirror here, that the same principle can be given. By rotating a mirror, there can be a continuous scan of this laser line throughout this surface. But then the scanning time has to be fast. So it could be through a scanner, or then multiple line projector is also available. So multiple line, like 50 line, 100 line, something, that many lines projectors are also commercially now available. So that can be directly also used. And in case of this illumination, projector illumination, of course, flexibility is much more. We can simply load through a USB whatever pattern that can be projected. So therefore, that has a much more flexibility. Only thing concern is the life of the working life of the lamp. So generally for structural integrity monitoring, this projector based illumination is used. A pattern, a very fine pattern of lines, two-dimensional line is projected onto the structure. So then the pattern, the like shifting of the on the image plane, this kind of shifting will be there. There will be large number of lines and the shifting image will be there. So accordingly, the full three-dimensional picture can be quantified by the displacement of the individual lines at every pixel. So that way a three-dimensional non-contact measurement can be done of the full surface. There are two concerns of three-dimensional this one. One concern is the visibility. In this case, of course, we have a plate here, and the undulation we have assumed to be very small. So roughly, because this is a well-controlled steel plate manufacturing process, or some plate manufacturing process, this will be hardly in millimeters undulation maximum. Even millimeter undulation, if it is there, the sheet will be rejected in the quality inspection. Only thing, if it is rejected at the quality inspection, the cost incurred is much more, because you have all those stages of process done before finally if it is rejected. So the cost incurred is very high if it is not controlled well. So that is a concern. But for three-dimensional structure monitoring by this method, there will be visibility problem. Visibility problem means because you are viewing through this lens a three-dimensional thing, there will be occlusion. So that visibility problem need to be solved by taking this projection at various angles. Usually, again, there would be a angular variation need to be provided to have a large 3D. So that's why initially I have written that it has been assumed that the standoff distance is much larger compared to the undulation. That is, there in that case, there won't be any visibility problem. So I think these two industrial applications, we have also many other laser-based industrial applications, but I thought these two I will discuss. There is of course a I think another one we can just discuss a little bit that has been also given in the Doeblin. Laser-based velocity meter or laser Doppler velocity meter. There are some other important application is there. It is particle sizing, etc. So those are also very important industrial application. But this one is there in the Doeblin, so let me discuss a little bit about laser Doppler. We have discussed about ultrasonic Dopplers. The principle is same, only thing ultrasound, the frequency is in the megahertz. So therefore, if the first hand Doppler shift is counted, then the shifted frequency would be of the kilohertz and hertz, which can be easily measured. However, laser, the frequency is 10 to the power 15 hertz. So therefore, it will be very difficult to measure the direct Doppler shift accurately, because that will also be at a very high frequency. So that's why laser Doppler velocity meter is based on a differential Doppler principle. So that means there are two beams having frequency shift. One is at plus delta f, another is at minus delta f. So again, there can be laser Doppler velocity meters having many types of construction, but what I am again drawing here is corresponding to some rolling mill. So that means the velocity of the plates need to be controlled. Why that is so? Because basically the mass flow is constant at the input and the output. So therefore the width of the plate depends on the differential velocity. So basically, this is a beam splitter. So which make two beams out of one beam. So then these two beams are put at an angle. Generally, that angle is controlled by this biprism. Biprism means two prisms are fused inside. So therefore, the two beams are created at a certain angle depending on the thickness of that biprism. Or beam splitter is also the prism angle is changed. So to make these two angles. So two laser beams here, okay, and then this two laser beam is converged by a lens, okay. This lens is this is basically a lens of this type. So that means here glass is there and this side is cut. So this is cut to for the purpose of collecting the scattered light. Onto a photo detector. So again we have a imaging lens which is focused onto the photo detector, and correspondingly this photo detector output is fed to an spectrum analyzer or a FFT analyzer. So this is a dual beam laser Doppler velocimeter. The advantage of dual beam is that here what is happening is that there are two beams which are basically intersecting. It's focused, two beams are focused by these two lenses. So now what is happening here, the cross section, beam cross section is created. Now in the frequency range, that frequency shift, I think time is, see it is just like that ultrasound 1 2b by lambda sine alpha by 2. This angle is alpha, sine alpha by 2. Now this is the measurement volume. So therefore, if this plate is passing through this or object is passing, then only there will be corresponding frequency shift corresponding to twice phi by lambda sine alpha by 2. On other cases, it will be at a very high frequency. So that makes the measurement simpler and noise less noise prone, because Doppler scattered frequency can come from any place, dust, particle, etc. in industrial environment. So therefore, we have to have a precise measurement volume from where we are collecting this radiation. And then that frequency shift is measured. So this is the basic principle. we can discuss maybe a little bit next day.